In Mexico, there is much talk about chicken needing to be washed. However, this is a bad idea. But why? Well, when a stream of water falls, many droplets splash from the surface in the water is heating. If we wash the chicken under the stream of water of the kitchen sink, bacteria that we can see are entering those mini droplets. Then it will contaminate anything that touches, such as your kitchen utensils or other food that may be around. This is called cross-contamination. Food of animal origin usually bring pathogens that previously lived in the bodies of the animals when they were alive. Due to the poor handling on the production line, these pathogens can get to us in the animal parts or their derivates. This contributes to the high rate of gastroenteritis worldwide. And the leading cause of this disease is Campylobacter jejuni. This bacteria usually lives in the chicken's intestine, and unfortunately, in recent years, it has been seen that it's multi-resistant to different types of antibiotics, which make it challenging to eliminate from someone becomes infected. As we see in this graph, in 2020, a study was carried out on more than 200 genomes of different Campylobacter species, and no signs of antibiotic resistance were even found. But hey, science is here to help. Recently, nanomaterials that can inhibit the growth of this type of pathogenic organisms are being developed, generating alternatives to medication to which they are resistant. As we can see in this image, nanoparticles can damage bacterial cells by attacking them differently. In this work, using an edible mushroom called Ganoderma sessile, we generate silver and copper oxide nanoparticles through green synthesis, because being environmentally friendly during this process is essential. And through these 3 years that I have been working on this project, we have obtained good results. We have inhibited this bacteria growth in laboratory tests with these nanoparticles. As we can see in this graph, both copper oxide and silver nanoparticles inhibit the growth of C. jejuni. And we can see in the image obtained with electron microscopy, in panels A to D, we see the interaction of the nanoparticles with the bacteria. And the bacteria is intact in panels E and F with no nanoparticles. Furthermore, it's the first time this methodology has been explored to search for an eco-friendly nanoparticle alternative against this bacteria of human health concern. And the next thing is to find a way to apply these nanoparticles in the food production line through a spray to disinfect utensils and surfaces, or at home to give us more security. But, well, we are on the way. And for this time, this is all. Thank you for your attention.